this video I'm going through multiplying, right from basics up to multiplying decimals. Okay, so starting off, what is multiplying? Okay, let's take an example of 2 times 3. What does that actually mean? You could say 2 of 3. Okay, so if you've got 2 3s, that'll be a 3 and another 3, which will give us 6. So essentially what multiplying actually is repeated addition. So it's just adding numbers over and over again depending on the situation. As an example, if you had 2 packs of 3 batteries and 4 packs of 5 batteries, and you want to know how many batteries you had altogether, here you need, you could do it through adding. So to show you the repeated addition, 2 packs of 3 batteries. Well, if you've got 2 packs of 3, you've got 3 batteries, which gives us 6 batteries. If you had 4 packs of 5 batteries, 5 in the first pack, 5 in the second, 5 in the third, 5 in the fourth pack, which will give you 20 batteries. So altogether you have 26. And when you start to get used to this, you can start to realise that actually instead of repeating that addition like that, what you can write that out as is 2 times 3, which is 6, and 4 times 5. 20. Altogether you get 26 batteries. And I guess what I want you to understand from this is when you're multiplying, okay, an important thing to realise, it wouldn't actually matter if you did it backwards. You could do 3 times 2 or 5 times 4. That's a property known as commutative. Okay? Multiplying is commutative. It doesn't matter which way round you do it. You could do 4 times 5 or 5 times 4. And to illustrate that, okay, if you've got the standard multiplication grid as you would normally have there, okay, these are your basic times table that you need to memorize up to 12 times 12. And what you'll find is that there's an interesting pattern there because, for example, if I did 3 times 2, which is 6, it would be the same as 2 times 3. You can see the pattern on either side. For example, the 10 there and the 10 there are split along that diagonal, and that diagonal has a special pattern there. Those are your square numbers. Okay, for example, 9 times 9 is 81. The reason why we call it the square numbers, if you think about that, if you had 9 across and then 9 in another dimension, what you'd end up with is an area of 81 units of that. Now, what would we do in the instance where you had to multiply something that's bigger than 12 times 12? And if you know up to 15 times 15, that's what I would say your grade 9 students would memorize that point. But ultimately, all you actually need to know is up to 10 times 10. If you know all your times tables up to then, you can multiply anything. And to give that as an example, I mean, if you had 734 times 26 batteries, that involves a more written method rather than something that you could work out in your head. These are the ones that you need to be able to work out in your head. In this case, you need to use a different method. And to illustrate that, there's lots of different methods that you could use. Okay, these are the 3 most common methods of multiplying. So in this example, I'm going to do 734 times 28. Now, your first method is what we call the grid method. And what we're doing with the grid method is we're splitting it up so that it's 734 times 28. So in effect, we're taking the same sum, 734 times 28, and we're splitting it up into hundreds, tens, and units. So you get your hundreds, tens, and units, tens, and units, the second number. And then making a little grid, you multiply those individually. Now, when you're multiplying this, for example here, you're doing 700 times 20, okay? If you think about what you're doing there, 700 times 20 is the same as 7 times 100 times 2 times 10. So the 20 is the 2 times 10, the 700 is 7 times 100. And again, using the properties of being mutually commutative, that means that you can do it in any order. An easy way to do this would be to do the 7 times 2 first, then multiply by the 10, and then multiply by the 100. So in effect, what we have here is 7 times 2, which gives us 14, times by the 10 gives us 140, and then times by 100, which gives us 14,000. Okay, so to show you in this one, that will be 3 times the 2, which gives us 6, and then we need to multiply by 10 and 10 again for each number. And this one we do the 4 times the 2, which gives us 8, and multiply by 10 again. So here it would be 7 times 8, which is 56, and you times that by 100. And this one you do 3 times the 8, which is 24, and you multiply it by 10. And finally you've got 4 times 8, which is 32. So once you've got all your numbers in that grid, at this point now you need to add them all together. So notice how I'm spacing the numbers out to make sure that we stay accurate, and I tend to do it in size order. It doesn't matter which order you add them up in. I tend to go from the largest all the way down to the smallest. So 14,000 plus 5,600 plus 600 plus 240 and then plus 80 plus 32. And when you add these together, gives us 2 on that end, 3 zeros, plus the 4 plus the 8 gives us 12, plus the 3 gives us 15. And we carry the 1 along and put our units in. In this case you've got 6 plus 6, which is 12, add the 2, which is 14, add the 1 gives us 15. Again, put down the unit and carry along tens, in this case 10,000. 4 plus 5 gives us 9, add the 1 gives us 10, then carry the 1, and finally you've got 2, which leaves us with our final answer. Another little hint here, every 3 digits represents 1,000, so either put a comma or leave a space. That gives us 20,552. Now, it's a good method, this one, but the drawbacks from here is, as you can see, it involves a lot of adding and it's quite a time-consuming way of doing this. It's good in that it splits it up into smaller sums, and if you had larger numbers, for example, if this was 7,440 and 2,820, for example, you could still do the grid, but it would be very laborious in terms of the adding. Okay, the next method to multiply, we're going to do the same numbers, 734 times 28. We're going to use what's known as the column method. And this is by far the most common way of multiplying that most people learn. So, spacing my numbers out nicely, I'm going to do 734 times 28. Now, your first step here is to realise what we're going to multiply is the top line by the units here. So it'll be 4 times 8, 3 times 8, and 7 times 8. And what that gives us, so 4 times 8 is 32, 3 times 8 is 24, add the 3 gives us 27, and then 7 times 8 gives us 56, add the 2 gives us 58. Okay, once you've done that, your next step then is to multiply This time we're going to be doing the same top line, but we're going to be multiplying it by, so 4 times a 2, 3 times a 2, and 7 times a 2. And what's important to remember here, that actually we're not actually multiplying by 2, we're actually multiplying by 2 zeros, so 20. So when multiplying this, the easy shortcut to get from there to there is to first add a 0 at the end. So because we're doing 4 times 2, 4 times 20 rather than just 4 times 2, we add a 0 at the end, and then the rest of it is just multiplying your individual digits because everything will have moved up a place value. So 4 times 2 gives us the 8, 3 times 2 gives us 6, 7 times 2 gives us 14. And once you've done that, I get rid of the numbers that we carried there. Okay. From this point, it's just a matter of adding these values together. So we've got 2 there, 7 plus 8 gives us 15, carry the 1 there. 8 plus 1 is 9, add the 6 gives us 15 again. Then 5 plus 1 plus 4, so 6 plus 4 gives us 10, carry the 1, that gives us 20. And again, it leaves us with the same answer, 20,552. Column method. Okay, now the last method that we're going to be looking at is what's known as the lattice method, sometimes called the Chinese method, or sometimes called the Lattice method. But ultimately it's using what's known as a lattice. Okay, so to show you how to do this, first of all, we start off with 734 written out, nicely spaced out again. And this time we're going to multiply it this way by 28 going downwards. And what we want to do here is build what's called a lattice, which is basically just a square for each number. So each number gets its own space there going downwards, and each number has a space going across. And once you've done that, your next step here is to split the squares into diagonals. So once you've done that, the reason why I like this method, because at this point, in terms of the actual calculations, the only thing you'll ever need to do is up to 9 times 9. And to show you this, so the answer here will be 7 times 2, which gives us 14. This box will be 3 times 2, which is 6, so we write 0, 6, and 4 times 2, 0, 8. Similarly down here, 7 times 8 gives us 56, 3 times 8 gives us 24, and then 4 times 8 gives us 32. And then to work out your final answer, you add up all the different diagonal, what I'd like to call the little pipes. So if you imagine those as diagonal pipes, the first one is just 2, and this one, you add them together, so 8 plus 3 is 11, add the 4 gives us 15. And just in the same way as we do with the column, we put down the unit and we carry any remainders or the tens along. So in this case, 6 plus 2 is 8, add the 1 gives us 9, add 6 gives us 15 again. So again, I put the 5 down and carry the 1 along in that pipe. So 1 plus 4 gives us 5, add the 5 gives us 10. And a common mistake here, people would think that's 11, but don't forget we're always adding the individual digits here. So that's 1 plus 1, which is 2, which gives us 20,552. Now, whichever method you choose to use is entirely up to you. Personally, I've always found that the lattice method, since I've learned this method, it makes life so much easier. It does take a little bit more working in terms of drawing out the boxes, but once you get used to that, it makes it a lot easier. And I'm going to show you why I think this is the best method with the next